I'm Tim. This PCB Sync.
What is RO4003C? L4003C is a glass fiber reinforced hydrocarbon and ceramic composite material. It aims to combine the high-frequency electrical properties of PTFE glass fiber materials with the easier processability of epoxy glass fiber materials. Simply put, it's not your typical F24. Nor is it a traditional PTFE material. Instead, it's a material that balances high performance, processing difficulty, and cost. It's a radio frequency microwave material. Let's first look at the most important parameters of L4003. Its process dielectric constant is 3.38, with a tolerance of +0, -0.05, which is used for transmission line dimension and electrical length design values. REX also provides a design dielectric constant of 3.55. Its loss factor at 10 GHz and 23 degrees Celsius has a typical value of 0.0027. It's important to note that the 3.38 and 3.55 values are tested using different methods and serve different purposes. When calculating impedance and phase, you can't mix these two values together. Let's look at a project. On the screen is a 5.8 GHz open source distributed phase shifter. J2 is the RF input port, G1 is the RF output port, and G3 is the RF phase control. TL1 to TL4 in the middle are transmission line structures, which work together with diodes. Along with other matching components, they achieve different phase shifts for the signal. In such high-frequency circuits, the PCB traces are no longer just simple connecting wires. Their length matters. The trace width, board thickness, and node length all jointly affect the impedance and electrical length. If the board's low K value changes, even if the physical length of the copper trace remains the same, the signal passing through this may experience a change in the resulting phase as well. This open source project was originally designed for 0.6 mm thick F24. If we want to switch it to L4003C, we can't just swap the material. Just changing the material and keeping the original layout for production won't work. First, we need to reconfirm the board thickness because RO4003C comes in several standard thicknesses. Second, we need to recalculate the transmission line width to ensure the new stack-up still meets the target impedance. Third, we have to recalculate the transmission line length because the design's dielectric constant, dk, has changed, so the physical length required to achieve the same phase shift will also change. Finally, we also need to consider the roughness of the copper foil, surface treatment, connectors, and manufacturing tolerances, because these factors will affect insertion loss and phase results. Another advantage of RO4003C is that it can use many processing methods similar to FR4. It can be processed using standard epoxy glass fiber techniques, and compared to microwave materials, it usually doesn't require special via treatments. Secondly, in terms of processing, it also shows that RO4003 does not require any special treatment before metallization. And it is compatible with chemical, copper, and direct metallization processes. However, this doesn't mean that all FR4 production processes can be directly copied. In actual production, you still need to adjust according to board thickness, copper thickness, stack up, and hole diameter, and re-establish drilling, lamination, and impedance compensation parameters. RO4003 is commonly used in controlled impedance transmission lines, filters, power dividers, couplers, antennas, and other RF and microwave circuits. Another thing to note is L400S itself does not meet the UL94V0 flammability rating. If you are designing high-end RF PCBs, PCB Sync can assist with stack-up evaluation and impedance checking. DFM review, prototyping, and mass production, you're welcome to contact us.